now let's start with the first previous year question. This was asked in JEE Mains 2023. And this question is a combination of sets and relations and ellipse. A fairly easy question. The only thing is you had to know the concepts of both sets and relations and ellipse. Let's look at it. In a group of 100 persons, 75 speak English and 40 speak Hindi. Each person speaks at least one of the two languages. If the number of persons who speak only English is alpha and the number of persons who speak only Hindi is beta, then the eccentricity of the ellipses. So basically first we need to find out alpha and beta using sets and Venn diagram, and then from that we can find out the eccentricity of our ellipse. So whenever there is a question related to sets, again it is recommended for you to draw Venn diagrams. So same thing we will be doing here. Let's draw a Venn diagram. This is our English. This one is our Hindi. And this is our universal. So there are in total 100 persons, and they have mentioned that each person speaks at least one of two languages. That means our universal, there is nothing outside here. Now let us assume that the number of persons who speak both Hindi and English are X. So that means the number of people who speak only English in this box would be 75 minus X. And those who speak only Hindi would be 40 minus X. And we know that since universal is 0, that means the sum of all these three is equal to 100. That means 75 minus X plus 40 minus X is equal to 100. And from here we can see that X would be equal to 115 minus 100. And this would be equal to 15. That means the number of people who speak both Hindi and English are 15. That means the one who speak only Hindi would become 40 minus 15, 25. And the one who speak only English are 75 minus X, which is our 60 number of people. And it has mentioned that the question has given us that if the persons who speak only English, that means 60 are the people who speak only English, is equal to alpha. And the number of persons who speak only Hindi, that means 25, is equal to beta. So we've gotten the value of alpha and beta. Now let us replace this in our ellipse equation, and then let us find out the eccentricity of that ellipse. So I'll take this to the next page. 25 beta square x square plus alpha square y square is equals to alpha square beta square. Alpha square beta square. Alpha square beta square. And from here we know that alpha is equal to 60 and beta is equal to 25. So let us now replace these values. What we are getting, 25 beta square, this makes it 225 x square plus alpha square 3600 y square is equals to alpha square beta square. So it is 60 square 25 square. Let us take this below and divide it, or first we can cancel 25 from here and let us divide this entire equation. We would get x square upon 60 into 60 upon 2 to 5 plus y square upon, I have taken the 2 to 5 below in the term of A and 3600 in the term of B. 60 into 60 into 25 upon 3600. Here there will be a 25 as well. So from here we can cancel out. So B square is 25, and from here 25 25s are 5 5s are 5 15, 5 12s are 60, 5 12s are 60. So what do we get as our equation of ellipse? Our equation of ellipse is x square by 144 plus y square by 25 is equals to 1. Now we have to find out what was asked to us in the question, eccentricity. So from here we know that a square is equal to 144 and b square is equal to 25. So eccentricity, what is the formula of e square? 1 minus b square by a square. So from here we can write 1 minus b square by a square. This would transform to 144 minus 25. This would give us 119 upon 144. So this becomes 119 by 12 root under e. This is our answer. So as I mentioned at the start of the question, very easy question. The only thing is you had to understand the concepts of Venn diagram that has been used here, and again finding the eccentricity of an ellipse is very easy. Let's look at another question. This question was asked in JEE Mains 2022. If the length of lattice rectum of the ellipse x square plus 4y square plus 2x plus 8y minus lambda is equals to 0 is 4, and L is the length of its major axis, then lambda plus L is equal to. So we have been given a standard ellipse which has a center in it. So let us try to convert this in the standard form. This here is the expanded form. Let's try to convert this in the standard form. So this would let us bring all the x terms together, plus 2x plus 4y square plus 8y, and let us take lambda to the other side. Now, how can I make this term a complete square? X square plus 2x. That means if I add 1 here, this would become a complete square, x plus 1 whole square. And this one, what if I add a term 4 here? This would become a complete square, which would be 2y plus 2 whole square. So let's do that. X square plus 2x. I've added this term 1 plus 4y square plus 8y plus 4 is equals to, now to balance this 1 and 4, I'm going to add it here as well. So I've added it on the other side. So now what are we getting? X plus 1 whole square plus 2y plus 2 whole square is equals to lambda plus 5. Now if I were to take this lambda plus 5 below and I was to take this 2 outside from this equation, what would I get? X plus 1 whole square by lambda plus 5 plus y plus 1 whole square upon lambda plus 5 by 4 is equals to 1. So we've got the equation of our ellipse in standard form. This means that our a square is equals to lambda plus 5 and our b square is lambda plus 5 by 4. Now what are the information that have been provided to us? The length of the lattice rectum is 4. Length of the lattice rectum is 4. That means, how do we write the length of lattice rectum of any ellipse? It is 2b square by a. So let us replace that value here. 2 times of b square is lambda plus 5 by 4 upon a. What is the value of a? Root under lambda plus 5. And this value is equal to 4. Now let us try to solve this equation and find out the value of lambda. So from here we would get 4 times of lambda plus 5 is equal to lambda plus 5 by 2. Let us take this 2 to the other side and square both sides. We would get 64 lambda plus 64 into 5. This is equal to lambda plus 5 whole square. Now we can simply form a quadratic in terms of lambda and we can find out the values of lambda. Again, there would be 2 values that would come out of lambda. One would be rejected and the other one which we would choose will be used to find out our answer. So let us solve it more further. 64 lambda plus 320 is equals to lambda square plus 25 plus 10 lambda. So taking all these things to one side, we get minus 54 lambda minus 295 is equals to 0. So from here we can see that lambda, that this equation is nothing but factors of 59 and 5. So if we multiply 59 and 5, we would get 295 obviously. So this becomes lambda minus 59 whole square, into lambda plus 5 is equals to 0. So from here we get two values, lambda is equal to 59 or lambda is equals to minus 5. Now which one are we going to choose? So if we look at the equation of ellipse here, the number at the denominator is lambda plus 5. So in the denominator we have lambda plus 5. That means lambda can plus 5 can never be equal to 0, because if there is a value which is 0 in the denominator, then the value of the entire equation would become undefined. That is why lambda cannot be equal to minus 5 from here. That means this value is rejected and we take this value here. Now, so first thing that we've gotten is we've gotten the value of lambda, which is 59. Now let's try to find out L. What has been given to us about L in the question? L is the length of its major axis. So L is nothing but 2a. So what is a here? L is twice of root under lambda plus 5. So we've gotten lambda is 59. So this would become 2 times of root 64, which is 8. So 8 to the 16. We've gotten L as well. So what was asked to us in the question? L is 16, 59 plus 16, and the answer that we would get is 75. Again, a very easy question, just the basic terminologies of ellipse that have been used in this question. And the only thing that you had, the catch here, was to convert this entire expanded equation of ellipse into the standard form with center, and then the rest of the calculation becomes very easy. Let's look at the next question. Let's look at this question. If the ellipse x square by a square plus y square by b square is equals to 1 meets the line this on the x-axis and the line this on the y-axis, then eccentricity of the ellipses. So first thing that we know about this is the ellipse that has been provided to us is a standard one, where this vertex can be set to be a comma 0, since it is a standard one, and this one can be 0 comma b. Now it has been said to us that this line meets the ellipse on the x-axis. That means this line is meeting the ellipse on the x-axis altogether. All these three curves are getting intersected at the same point. That means it can either be here or here. So if I was to take this line and put y is equals to 0, since the point here being is it is intersecting it on the x-axis, and at x-axis all coordinates of y are 0. So if I put y is equals to 0 in this equation, I would get x is equals to 7, which is a positive number. That means this line is intersecting our ellipse at this point, and our a becomes 7. So we've gotten the value of a. Now let us try to find out the value of b. It has also mentioned that the line x by 7 minus y by 2 root 6 is equal to 1. This thing intersects the ellipse on the y-axis. That means if it is on y-axis, that means we can put x is equal to 0. So what would we get? We would get y is equals to minus 2 root 6. And since it is intersecting the ellipse as well, so it can be either this point or this point. Obviously we have to reject this point, because this point would be, the b here would be positive, and here, which is 0 comma minus b, this would be negative. That means here we've gotten minus b is equal to minus 2 root 6. Since the y is minus 2 root 6, so b becomes 2 root 6. That means from here now we know what our equation of the ellipse is. It can be written as x square upon a square, which is 49, plus y square by b square, 24, is equals to 1. This is our equation of ellipse. Now what has been asked to us? We have to find out the eccentricity of this ellipse. Again, easy. E square can be written as 1 minus b square by a square. So e square is equals to 1 minus, what is b square? 24, and a square is 49. So from here we would get e square is equals to 25 by 49, and E is equals to root under would give 5 by 7. This is our answer. Now you might be thinking that since E is equals to root under 25 by 49, so we can say that E would be equal to plus minus 5 by 7. However, you have to reject the negative 1 here. The reason being, in the first slide of this lecture, we had studied that E for an ellipse belongs from 0 to 1. That is why the E cannot be negative, and so we get 5 by 7 as our answer. Again, very easy question. There was nothing much asked here. They had already provided you with the information that the line is intersecting the ellipse on the x-axis and y-axis. So you can put any one of the coordinates 0 and get the vertices of the ellipse, and that's how you solve this question. Let's look at the other one. Let f of x is equals to x square plus 9, gx has been given, and a is equals to f of gx, and b is equals to g of fx, if E and L denote the eccentricity and latus rectum of the ellipse. An ellipse has been given, then 8e square plus L square is equal to. So basically we need to, for this ellipse, first we need to find out the value of A and B. A and B. Here there has been a printing mistake. This would be A square by B square. So again, a combination of functions and ellipse. So let us try to solve this question. Since we know f of x is equal to x square plus 9, g of x is equal to x by x minus 9, and we know a has been given to us, which is f of g of 10. That means first let us find out what g of 10 would be. This would be 10 by 10 minus 9, which would be equal to 10. That means g of 10 is 10. So a can be written as f of 10, which would be equal to 10 whole square plus 9, which makes it 109. So a we've gotten to be 109. Sorry, this is a only. So now let us try to find out b. B has been given to us as g f of 3. So let us first find what f of 3 is. F of 3 would be 3 whole square plus 9, which is 18. That means we have to, since this value is 18, so we can find out g of 18. G of 18 would be 18 by 18 minus 9, which makes it 2. That means we've gotten the value of b to be 2. So we've got our a and we've gotten our b. Now what has been asked to us, we have to find out the eccentricity and length of latus rectum. Of course, this is a square and b square. Let us find out the length and length of latus rectum first. So length of latus rectum would be equal to 2b square by a, and what is our b square? This would become 2 into 2 square by a, and this would become 2 2s are 4, 4 2s are 8 by 109. Now let us find out the eccentricity. This can be written as 1 minus b square by a square. So eccentricity squared would be equal to a square minus b square by a square. So this can be written as a square, 109 whole square, minus b square, which is 4 upon a square. This is our eccentricity. Now in the question we have been asked to find out 8 e square plus L square. So let us try to convert these equations in this format so that we do not have to do this long calculations of 109 whole square. So 8 e square, we know what is e square. It is 109 whole square minus 4 upon 109 whole square plus L square. This would become 109 and whole square. So we can take 109 square common here, whole square common, and now let us try to add these two equations. So from here we would get 8 into 109 whole square minus 8 4s are 32 plus 8 8s are 64. So this can be written as 8 times of 109 whole square plus 32 upon 109 whole square. Now there was a catch that was given here in this question. We know that 8 into 109 whole square upon 109 whole square is equal, plus 32 by 109 whole square. We can take this separately. Now in this term 109 would cancel 109, and what would we get? I'm continuing this here. This would get 8 plus 32 by 109 whole square. Now 109 whole square is a very large number. Of course, this would come in terms of 10,000. So this would become 0.0032, somewhere around that. So ultimately, since this is a very small number, we can reject it. That means we just cancel this to be 0, and so we give our answer to be 8. Our answer is 8. So again, a very easy question. There wasn't much asked either from function or from ellipse. The only catch here was at the end of the question, where you had to assume that 32 which has been added here is very small. So even if I remove it or I reject it, it does not make much difference. And in the question that was asked in JEE Mains, there were options given. So by looking at the options also, you could have find out that 8 was the very closest answer that you could have gotten, and 8 you could have ticked as the correct answer. Now let's move on to the next question. Now let us look at this question. Was asked in JEE Mains 2024. This is a mixture of ellipse, circle, and the concepts of locus and a few concepts of straight line as well. So a good question, lengthy question, although a very easy question. Let P be a point on the ellipse. Let the line passing through P and parallel to y-axis meet the circle at point Q such that P and Q are on the same side of the x-axis. Eccentricity of the locus of point R on PQ such that the ratio as P moves on the ellipse. So we need to find out the locus of R, and then we need to find out the eccentricity of that locus. So first of all, let us draw what has been given to us in the question. There is a circle that has been provided to us whose radius is 3. So this point is 3, 0, 0, 3. This is our circle, and there is an ellipse. Now from here we can see that in this ellipse A is equal to 3 and B is equal to 2. That means our ellipse would be concentric to this circle. The center would be same for both, and the value of A is equal to R. The R radius for this circle is 3, of course. And what has been told to us in the question, that there is a line which is parallel to y-axis. That means somewhat like this. It meets the ellipse on point P, and it meets the circle on point Q. So let us assume that this P point, since it is on ellipse, it is A cos theta, comma B sin theta. So we can write this as 3 cos theta, comma 2 sin theta. And Q, if you remember, we had studied this concept in circle, that the parametric form of circle is written as r cos theta, comma r sin theta. So here we can write this as 3 cos theta, comma 3 sin theta. So we've gotten P and Q. Now what has been told to us, that there is a point R which divides P and Q in such a way that the ratio is 4:3. Then we need to find out the locus of R. Let us say that the R is point H, comma K. So if I was to use this diagram to understand, so this is RH, comma K. Q becomes 3 cos theta, comma 3 sin theta. P is our 3 cos theta, comma 2 sin theta. And this divides this entire line in the ratio 4:3. Now again, the straight line, we had studied this concept. When a point divides any two points in certain ratio, then how are we going to find out the coordinates of that point? So from here we can see that H, the coordinates of R, H can be written as 12 cos theta, since 4 into 3 cos theta, and 3 into 3 cos theta, plus 9 cos theta divided by 7. And K can be written as 4 times of 3 sin theta, which makes it 12 sin theta, plus 3 times of 2 sin theta, which makes it 6 sin theta by 7. So from here, let us find out the value of cos theta and sin theta. If we know the value of cos theta from this equation and we know the value of sin theta from this equation, then we can use this trigonometry concept, which is cos square theta plus sin square theta is equals to 1. there from there you can see that we can get a 2-degree equation on h and k as well, and so that would be either our ellipse or hyperbola. And since we are studying ellipse, so it is obviously going to be an ellipse, and from that we can find out the eccentricity. So this would become 7h by 21. 7h by 21 is equals to cos theta, and this would become 7k by 18 is equals to sin theta. So let us use the trigonometry concept, which is cos square theta plus sin square theta is equals to 1. So we can write this down as 7h whole square upon 21 whole square plus 7k by 18 whole square is equals to 1. So we can replace h and k by x and y, and since we know that this is transforming into the equation of an ellipse, let us try to bring each and every coefficient of x and y in its denominator. So what would we get? X square upon 21 by 7 whole square plus y square by 18 by 7 whole square is equals to 1. So this we found out the locus of R. This is our locus of R. We found out the equation of our ellipse. Now what has been asked to us in the question? We need to find out its eccentricity. So it is nothing but 1 minus b square by a square. So let us write 1 minus b square is 18 by 7 whole square upon 21 by 7 whole square. 7 and 7 gets cancelled, so we have left ourselves with e root under 1 minus 18 square by 21 square. And once we cancel and solve this equation, what are we going to get? The value of e to be 117 by 21, root 117 by 21. This would become our answer. Again, a very easy question. The only thing is that you needed to visualize this diagram that has been given. They have given us two concentric curves. One is an ellipse and the other is a circle. And you had to remember that the parametric form of how circle and ellipse both are written. If you knew that, this question would have become very easy for you to solve. Let us move to the next. Let the maximum area of a triangle that can be inscribed in this ellipse, an ellipse, standard ellipse is given, is greater than 2, having one of its vertices at one end of the major axis and one of its sides parallel to the y-axis, be 6 root 3, then the eccentricity of the ellipse. Again, very easy question. We need to first draw how our ellipse looks like. This is our ellipse. Let's say this is our a comma 0, as the ellipse is x square by a square plus y square by 4 is equals to 1. We know a and b is equals to 2. A is for the time being a only. Now it has been given that one of the vertices of a triangle is at the end of major axis. That means it is here. And the other sides are parallel to the y-axis. That means they are somewhat like this. This is our, now this line is of course parallel to the y-axis. Now let us assume that the triangle is PQR. We found out our P point, this is our Q point, this is our R point. Let us assume that the Q point is in parametric form, which is a cos theta, comma b sin theta, and b we know is 2 sin theta. So what would R become? R would be a cos theta, since the distance from the x-axis is same for R and Q, and b would become minus 2 sin theta. Since it is just, the height is same, however it is just below the x-axis, that is why R would become this. Now let us try to find out the area of this triangle, which is maximum. Now we know that the area of triangle is calculated as half into base into height, and from here we can see that the height is this one and the base length is this. That means our base length is this height here. We know this is 2 sin theta. That means our base is twice of 2 sin theta, which makes it 4 sin theta, and our height would become a minus a cos theta, since we know that this distance is a and this distance is a, this distance is a cos theta. That means our height of the triangle would become a minus a cos theta, which can be written as a 1 minus cos theta. Now let us try to find out the area of triangle. Later on, after we've found out an expression for area, we are going to differentiate it in terms of theta and then equate it to 0 so that we can get a value of theta where the area becomes maximum, and then we are going to equate it to 6 root 3 and we will get our value of A. So once we get the value of A, then we can find out the eccentricity of the ellipse, which is a very simple task. So let us say this is A, half into the base is 4 sine theta, 4 sine theta into height. Height is our A, 1 minus cos theta. So 2 and 2 gets cancelled. So this becomes 2 sine theta. Sorry, this, let us take the A here as well. 2A sine theta 1 minus cos theta. This is our A. Now let us find out dA by d theta. Let us try to differentiate this. So if you see, remember we had studied this in derivability, how we can differentiate this by product rule, keeping one constant and then the other differentiation of the other, plus keeping the other one constant and the differentiation of the first. So same thing we will use here. So this would become 2A sine theta into 1 minus cos theta would become sine theta, plus we keep 1 minus cos theta as it is and differentiate sine theta, that becomes cos theta. So what does this turn out to be? 2A sine square theta plus cos theta minus cos square theta. Now let us put this entire expression in terms of cos theta so that we have to deal with only one trigonometric function. 2A. Now sine square theta, this can be written as 1 minus cos square theta, because I hope you know cos square theta plus sine square theta is equals to 1. So sine square theta can be written as 1 minus cos square theta. Let us use this concept here. So this would become 1 plus cos theta minus 2 cos square theta. Now we can see that this is a quadratic and we have to equate this to 0, since dA by d theta, to maximize we have to make dA by d theta is equals to 0. So if dA by d theta is equal to 0, that means we can equate this equation as well to 0. 2A would get cancelled out because it is just a constant. 1 plus cos theta minus cos square theta, and by the look of this we can find out that cos theta would have two factors. One would be 1 and the other one would be minus half. If you try to satisfy it 1, if you put 1, again it satisfies it. If you put minus half, still it satisfies it. So 1 cannot be taken as our cos theta, because if you look at the diagram, if cos theta is equal to 1, that means theta is equal to 0, and of course theta cannot be 0 and theta is measured from the center. If theta is 0, that means all the points would be at the same point, which is the vertex of the ellipse. So we can take minus half. Here our theta would be equal to 2 pi by 3. That means now 2 pi by 3 can be taken, and at this theta our area would be maximum. Now let's say if you were to make sure whether you are doing this thing correct or not, you can take out the second differentiation as well and see if it is coming out to be negative, because whenever we are finding maximum value, the double differentiation comes out negative, and whenever we are finding minimum value, the double differentiation comes out to be positive. So let us double differentiate this. What would we get? We would get 2A cos theta would turn into minus sine theta, and minus 2 cos square theta would turn into minus 4 cos theta plus sine theta. And you can see that this value here will always be negative. That means we are doing it correct, and our area of the triangle is always maximum when theta is equal to 2 pi by 3. If we put theta is equal to 2 pi by 3 in this equation, it will come out to be negative. So we can say that area is ultimately equal to 2A sine 2 pi by 3 into 1 minus cos 2 pi by 3, and cos 2 pi by 3 is minus half. So this becomes 3 by 2 ultimately. And sine 2 pi by 3, of course we know that this comes in the second quadrant, and in the second quadrant the value of sine is always positive. That means what would be the value of sine 2 pi by 3, this would become root 3 by 2. So 2a root 3 by 2 into 3 by 2. And what is the value of area as given in the question? 6 root 3. So root 3 and root 3 would get cancelled, 2 and 2 would get cancelled, 3 cancels this as 2 times, so a is equal to 4. We've gotten the value of a, which is 4. That means our equation of ellipse becomes x square by a. A we just found out to be 4, 16 plus y square by 4 is equals to 1. This is our equation of ellipse. Now to find out the eccentricity for this ellipse, we can write it 1 minus b square by a square. So e square can be written as 1 minus b square is 4, a square is 16, 4 ones are 4 fours are. This makes it 3 by 4 whole root under. That means e is equals to root 3 by 2. This is our answer. Again, a very easy question. There wasn't much concepts asked here. However, you had to understand that whenever maximum value or minimum value of any thing has been asked, you have to differentiate an equation and then equate it to 0. This of course we have studied in derivability and differential equations also. So this is not a very difficult question. So that was all for ellipse. Again, we've completed one more shape of geometry for conic sections. Now we will be looking into the last one, which is hyperbola. And to give you a brief, there is nothing much different from ellipse or parabola in hyperbola. There is just one extra thing that we will be studying, which is rectangular hyperbola. Apart from that, each and everything, the standard forms, the parametric forms remain almost more or less similar. So let's see you in the next lecture. Thank you.